Okay, we're doing 4.3, number 3, page 178. So I've started it in class, so I'll restart it just so we're on the right page. Okay, so we've got two objects. I just can't believe how difficult it is drawing on this. Okay, two objects. This one is 5 kilogram. This one is 3 kilogram. And I've given a lot of theory in class, so I'll skip a lot of the talking. So A, mu is FF. Yes, Nyla, it's FF over FN. Right. And remember, we redraw this. This is F. This is force applied. It's F friction. Give me one sec. Just want to make sure. Yeah, FF. Okay. Okay, we know that for static friction, we know that this is a linear curve here, and then it starts sliding. So here, this is static. Here, it's kinetic. This is linear, so it's 1-to-1, which means as long as it doesn't start moving, friction is simply the opposite force of F. So that just makes sense. Okay, so the students are pulling here. They measure a max static friction of 31.4 Newton. Okay, so to find Fn, U, so it's 8 kilograms times 9.8, right? Because that's the force that's pulling, that's pushing up the two objects together. FF is just this 31, so this goes here. You divide that, and you should get 0.4. Okay, so that's A. B, what's the magnitude of the tension here just before it starts moving? So on static friction, same thing. Okay, so this one I'll have to think with you guys. I don't remember the steps by heart. Okay. I have two objects. They're not accelerating, right? And if I can just find Ft here, I'll be done for B, right? This is all I need. So, now that I know this number, for my mu, I'll be able to work some stuff up here. Okay, this is weighing 5.0. This is weighing 3.0. Okay, so if you do the FBD of the second one, this is Fn, it's Fg, and the string is pulling by Ft here. So that means that FF, F small f, here has to be equal to Ft. So is there a way to find this here? So Fn anyway, it's going to be easy to find this because this here, this is just 3 times 9.8. 3 times 9.8. Scientific calculator. There we go. What was it? 3? 3 times 9.8. 29.4. Right. And since I know that, and since I know mu, ff and fn, right? I know this one. I'll be able to find this. And because I'll find ff, I'll be able to find tension. So this is quite straightforward. So if you just plug in your numbers, 0.4 times, fn, which is this, 29.4, you should get ff, which should be ft. What is this? 0.4 times 29, okay, so times 0.4, 1176. So I'm not bothering with the sig digs at this point. 3, so it'd be 2, right? So you'd have to round here. So that's actually 12 newtons. Pretty sure that's what the book has. Three, so 12, okay. Just have to here, of course. Okay, so C. Okay, so now there's displacement pushing down on the second one. Right? So Fn is still there, but the difference with B, this free body diagram, is that Fn will have 15, is it? Going to have 15 newtons more. So this Fn is equal to 29 plus 15. Should be able to do that. 30, 15, 45, so 44. 4 newtons. Because we have Fg and we have, I'm trying to call that F, I don't know, F new, F student, okay. So these two have to add up to this. Now FF will change, and so will tension. What are the magnitudes of the maximum static friction tension? Okay, so I should start with finding FF. So the coefficient doesn't change, right? So the equation is still the same. Mu equals Ff over Fn. This is meaning 0.4 equals, we're looking for this. we have Fn, which is 44.4. So we'll find Ff, which is Ft. So Ft equals 0.4, 44. So if you use digs on this, 2 here, if I remember well, I should keep 2. So this is 18. As final answer, okay? If you need this number further on, just use this one. Okay. Newton, did I do this right? 4.3, 4.3, yes. Okay. I have to find the new. So FBD for the second object, FT we know. What we are looking for is the new maximum force of static friction. This is Fn, G. Now there's a second force on this one. This is Ff. That makes sense because this object has a friction on its own. Right? So it's not, so there's tension and the friction. Okay, we know Ft, it's this. Ff, what's Ff? So mu is 0.4, same thing, right? 0.4. Now Fn, so 0.4. So this is still weighing 5 times 9.8. That's right. Okay. So times 9.8 times 5. That's 19.6. So if I just follow the logic of this, I define my new F total here. I just have to add these two. 6 plus. So use, you see what I mean here? This number, don't use the rounded number, use this one. Because you're still working. And when you'll be done, you round. You do the cyclic. Is that working? Is that working? It's looking good. That shot 19.6. 17.76. 37. This is the new Bristol. Let me check. Good. So that works. D, will your answers to C change if the student pushes down on the 5 object, the 5 kilogram object instead? Well, you have to redo all the calculations and see how it's affected. I cannot make a guess as to what it would do. Might get close to the same difference, but I wouldn't pronounce myself on that. Okay, so we're done.